Last time we discussed the use of potential outcomes for defining causal effects. In this video, we'll discuss the formal condition that needs to hold in order to estimate causal effects from observed data. This condition is called exchangeability. Suppose that we want to know the causal effect of an economic program on yearly income. We're able to collect data on people who use the program, A equals 1, and who don't use the program, A equals 0. The y A equals 1 potential outcome represents the income that would result if we forced everyone to use the program, and the y A equals 0 potential outcome represents the income that would result if we forced everyone to not use the program. The first half of the people in our study did use the program, so we observed the y A equals 1 potential outcome for them, but not the y A equals 0 potential outcome. And vice versa for the last half of the people in the study who did not use the program. Recall that to define average causal effects, ACEs, we take the average of the potential outcomes under treatment, use of the economic program, the average of the potential outcomes under no treatment, no program use, and we compare these average potential outcomes in some way, such as a difference or a ratio. Because we don't have data on the missing potential outcomes, we have to rely solely on observed data to estimate the ACE. Let's think carefully about what assumptions we would be making if we were to do that. Let's first think about the incomes of the program users. In estimating the ACE, we would need to use these observations to estimate the expected value of the treated potential outcome. Are these observations representative of the missing observations? Now let's think about the incomes of the program non-users. In estimating the ACE, we'd need to use these observations to estimate the untreated potential outcome. Are these observations representative of the missing observations? What might representative look like? The observed incomes in the program users would be representative of the missing data in the first column if that missing data took the same values and in the same frequency as the observed values. In this example, it means that the missing incomes are also $100, $120, $220, and $200,000, just like the observed incomes. The observed values are exactly a good representation of the missing values. Similarly, in the program non-users, the observed incomes would be representative of the missing data in the second column if those missing incomes took the same values as the observed incomes. In other words, for both potential outcomes, the distribution of the outcomes is the same regardless of the value of the treatment variable. In the language of probability, this means that the potential outcomes are independent of treatment. This is the notion of exchangeability. Formally, exchangeability is the property that the potential outcomes are independent of treatment. We'll express exchangeability with the notation shown here. The symbol in the middle means independent of. When exchangeability holds, observed outcomes are representative of the missing outcomes. That is, observed outcomes and the missing potential outcomes are exchangeable. They can be exchanged for each other. We can also express this as the treated and the untreated are exchangeable. The treated and untreated can be exchanged for each other because if we swapped everyone's treatment assignments, we would see the same data. This is the case in our example here. Because of exchangeability, we can fairly compare the observed outcomes in the program users and non-users as an estimate of the causal effect of the economic program, even though the causal effect is technically defined in terms of missing data. When exchangeability doesn't hold, observed outcomes are not representative of the missing outcomes. In that situation, a comparison of the observed outcomes between treatment groups provides a measure of association between treatment and outcome, but not a valid measure of the causal effect. Let's look at an example of a lack of exchangeability. So why might exchangeability not hold? In our example, one reason could be a difference in education levels between the policy users and non-users. The policy users may be more educated than the non-users. Thus, as a whole, all potential incomes for those who use the program will likely be higher, purely because these people are on average more educated. And as a whole, all potential incomes for those not using the economic program will be lower because they're less educated on average. In our previous example where exchangeability held, the program users, technically unobserved, distribution of potential incomes under no program use matched the observed income distribution in the non-users. However, in this example where these people generally have higher incomes due to higher education levels, the distribution of these potential incomes takes on a higher set of values. Using the observed incomes to guess these missing potential outcomes is a bad idea because the observed incomes are lower than they should be due to lower education levels in the group doing the filling in. Analogous ideas hold for the program non-users. When exchangeability held, the non-users' distribution of potential incomes under program use matched the observed income distribution in the program users. But in this example, these people generally have lower incomes due to lower education levels, so the distribution of these potential incomes takes on a lower set of values. Again, using the observed incomes to guess these missing potential outcomes is a bad idea because the observed incomes are higher than they should be due to higher education levels in the group doing the filling in. In short, the key message to take away about exchangeability is that if exchangeability holds, comparisons of observed outcomes in the treated and untreated are fair comparisons of the potential outcomes that we want to be comparing in order to obtain causal effects. A potentially helpful way to frame lack of exchangeability is by drawing a connection to the saying, correlation does not imply causation. When people say that correlation does not imply causation, they're saying that a correlation between, say, an exposure and an outcome does not imply that the exposure has a causal effect on the outcome. They'll generally say something along the lines of, there could be tons of differences between the exposure groups. We can't know if the exposure is the thing actually causing the outcome. The part about tons of differences between the exposure groups is exactly what drives lack of exchangeability. Systematic differences between comparison groups of characteristics that affect the outcome. Let's talk about one more idea in this video. Is there an easier to achieve version of exchangeability? Our last example showed that a factor like education could lead to a lack of exchangeability if the treated and untreated had different education levels. It seems like there would always be some sort of factor like this that leads to the treated and untreated being incomparable, in which case hoping for exchangeability seems fruitless. There is actually another type of exchangeability that will be more generally achievable in practical settings. In some situations, exchangeability will not hold in the full dataset, but it may hold in subsets. Let's look at a graphical depiction of the lack of exchangeability example that we've just worked through. Looking at the whole dataset, we can look at the distribution of potential outcomes under no treatment in the treated and untreated, and the distribution of potential outcomes under treatment in the treated and untreated. In both cases, the treated and untreated have different distributions of potential outcomes, so exchangeability does not hold. The observed data are not representative of the missing potential outcomes, and we would have a biased estimate of the causal effect of the economic program on income if we directly compared the average income in the program users and non-users. So while exchangeability doesn't hold when looking at the entire data set at once, there's still hope for being able to estimate valid causal effects because exchangeability can still hold in subsets of the data. If we zoom in and filter down to different subsets of the data, exchangeability holds within those subsets. Here we look at subsets of the data defined by education, the variable z. For simplicity, education level has been recorded as either low or high, and for both of these strata, we repeat the process of looking at the distributions of both potential outcomes in the treated and untreated. Now, within these subsets of the data, these distributions don't differ between the untreated and treated. The observed data accurately represent the missing data. So the difference between the distributions in each education stratum is a stratum-specific causal effect. When exchangeability holds within subsets of the data, this is known as conditional exchangeability. The exchangeability that we discussed earlier in the full dataset is known as marginal exchangeability. When we express conditional exchangeability, we use the notation shown here. This can be read as the potential outcomes and treatment are independent given Z. This means that if we look at all subsets of the data defined by the values of Z, exchangeability holds in those subsets. In our example, Z was the education variable, but in practice, Z will need to contain many variables. In another data setting, subsetting the data by amount of education alone would likely not be enough to see exchangeability in the subsets. It may be the case that exchangeability does not hold even within education subsets because age and occupation also affect income and differ between the program users and non-users. To summarize, you can think of exchangeability as comparability of the treated and untreated, specifically comparability of the observed outcomes. When we endeavor to make causal inferences, we make the assumption that some form of exchangeability will hold. Generally, this will be conditional rather than marginal exchangeability. That is, we hope to measure the right set of variables such that conditional on those variables, exchangeability will hold. Exchangeability is a key assumption underlying results that present causal effects. We assume that we have conducted the study in such a way and measured the right variables for exchangeability to hold. The idea of exchangeability may seem abstract right now, but we'll make it more concrete with our next topic of study designs. How can we design studies and collect data in ways that facilitate exchangeability being plausible?